Hi, I'm Bob. Let's continue solving the exercises from the textbook, Microeconomics, Theory and Applications with Calculus, the 5th edition by Professor Jeffrey Perloff. We are currently in the second section, Capital Markets and Investing, of Chapter 15, which focuses on factor markets. Here's exercise 2.1. How does an individual with a zero discount rate compare current and future consumptions? How does your answer change if the discount rate is infinity? An individual's discount rate reflects the relative value an individual places on future consumption compared to current consumption. A higher discount rate indicates less value placed on future consumption. If a person's discount rate is zero, she views current and future consumption as equally desirable and places equal value on future and current consumption. If her discount rate is infinity, she places zero value on future consumption and only cares about current consumption. Let's solve exercise 2.2. If you buy a car for $100 down and $100 a year for 2 more years, what is the present value of these payments at a 5% interest rate? If the interest rate is I, the present value of a stream of payment is as follows. We can calculate terms one by one, or we can use the formula of the sum of a finite geometric series. Let's go to exercise 2.3. How much money do you have to put into a bank account that pays 10% interest compounded annually to receive annual payments of $200? The question is about the present value of a stream of payment. Using the formula of the sum of an infinite geometric series, we can obtain the result. Let's answer exercise 2.4. Pacific Gas and Electric sent its consumers a comparison showing that a person could save $80 per year in gas, water, and detergent expenses by replacing a traditional clothes washer with a new tumble action washer. Suppose that the interest rate is 5%. You expect your current washer to die in 5 years. If the cost of a new tumble action washer is $800, should you replace your washer now or in 5 years? Explain. We use the net present value approach to compare the situations where we replace the washer now or in 5 years. We will find which case gives us a higher net present value. If we replace the washer now, the present value of the costs is $800, and the present value of the returns is $1,600. We assume the new washer lasts forever. The net present value of replacing the washer now is $800. Next, we consider the case where we replace the washer in 5 years. The present value of the costs is around $626.82, and the present value of the returns is around $1,255.64. The net present value of replacing the washer in 5 years, $626.82. It is lower than the case where we replace it now, so we should replace the washer now. Let's find answers to exercise 2.5. You plan to buy a used refrigerator this year for $200 and to sell it when you graduate in 2 years. Assuming that you can get $100 for the refrigerator at that time. The rate of inflation is 0, and the interest rate is 5%. What is the true cost of the refrigerator to you? We use the net present value approach to solve the problem. The net present value of purchasing the refrigerator equals the present value of returns minus the present value of the costs. The present value of the costs is $200, and the present value of the returns is $90.7. The net present value of the true cost is $109.3. Let's go to exercise 2.6. You want to buy a room air conditioner. The price of one machine is $200. It costs $20 a year to operate. The price of another air conditioner is $300, and it costs only $10 a year to operate, assuming that both machines last 10 years. Which is a better deal? The difference in the prices is $100, and the difference in the operation costs is $10 per year. Suppose the discount rate is 0. The difference in the operation costs over 10 years will be $100, which equals the difference in the prices. For any discount rate or interest rate that is above 0, the present value of the difference in the operation costs is smaller than $100. It makes the $200 machine a better choice. Let's solve exercise 2.7. Two different teams offer a professional basketball player contracts for playing this year. Both contracts are guaranteed, and payments will be made even if the athlete is injured or cannot play. Team A's contract will pay him $1 million today. Team B's contract would pay him $500,000 today and $2 million 10 years from now. Assuming that the rate of inflation is 0, our pro is concerned only about which contract has the highest present value, and his personal discount rate is 5%. Which contract does he accept? Does your answer change if the discount rate is 20%? Contract A's present value is $1 million. We calculate contract B's present value. If the personal discount rate is 5%, contract B's present value is higher than $1 million. The player will accept contract B. If the personal discount rate is 20%, contract B's present value is lower than $1 million. The player will accept contract A. Let's address exercise 2.8. You are buying a new $20,000 car and have the option to pay for the car with a 0% loan or to receive $500 cash back at the time of the purchase. With the loan, you pay $5,000 down when you purchase the car and then make 3 $5,000 payments, one at the end of each year of the loan. You currently have $50,000 in your saving account. For Part A, the rate of interest on your saving account is 4% and will remain so for the next 3 years. Which payment method would you choose? For Part B, what interest rate I makes you indifferent between the two payment methods? If we pay in full, the present value of the payment is $19,500 with the cashback. If we pay with the loan, the present value of the payment is smaller when the interest rate is 4%. We will choose the loan because it costs less. To find the interest rate that makes the two methods indifferent, we equate the two present values. It leads to a qubit equation with one unknown. Using the polyroots command in Stata, we can find the solution. It's around 1.77%. Thank you for watching this video and solving the exercises with me today. If it helps, please subscribe to my YouTube channel. Thank you. Thank you for watching this video and subscribing to my YouTube channel. See you next time.